Hi, I'm Steve Foskett, and welcome to another episode of the WPI podcast. Our guest today, WPI Organic Chemistry Professor Anita Matson, describes her work as being at the intersection of organic chemistry and visual design. Right in the middle of that intersection is a new series of graphic novels she created with UK-based illustrator Anton Brand that uses humor, storytelling, and art to guide students through the weeds of organic chemistry and toward promising careers in research, medicine, and more. Anita Matson, welcome to the podcast.
Thanks, Steve. I'm so glad to be here.
So what gave you the idea to produce a graphic novel about organic chemistry?
Honestly, I got tired of organic chemistry being treated like some ancient cryptic language that only the chosen few could decipher. It's honestly not sorcery, it's just carbon being dramatic. So I thought, why not make it visual, engaging, and maybe even a little bit fun? Plus, who doesn't love a good comic? If people can get emotionally invested in superheroes, they can handle a little nucleophilic attack.
Whatever you say. So who's the target audience for something like this?
I tried to make it a really open project. So anyone who's ever stared at a reaction mechanism like it personally offended them. But more specifically, it could be students or educators or really anyone who wanted to understand organic chemistry without wanting to throw their textbook out the window.
Yeah.
Traditional organic textbooks make it feel like you need a PhD just to survive the first semester, but this series is for people who appreciate a little humor with their hydrocarbons. Whether you're a struggling student, a curious nerd, or just someone who enjoys a good acid-base joke, this could be for you.
I really liked one of the jokes in one of the editions you had shared with us. There's this cute little base molecule thing laying on the couch in a therapist's office. And he's telling her that he wishes he was more stable. I thought that was funny, these puns that lend themselves well to the graphic novel format.
Oh, yeah, it's so true. Sometimes people wonder, if it's hard to find the humor in organic chemistry, but it is so easy. It's almost like a natural fit. There's so many aspects of chemistry that are kind of just naturally funny, like a lot of the jargon that people use. If you think about it relative to everyday life, it's just, kind of funny.
So what's your goal with this series?
Oh, well, I thought world domination might be a good end
For starters.
goal. But in all seriousness, I really want to make organic chemistry feel a little less like an intellectual hazing ritual and more like an adventure. Too many people are scared off by the way it's traditionally taught, and that's a crime because organic chemistry is really awesome. My goal is to make it visually engaging and a little more enjoyable. And if even one student goes from, I hate this, to, okay, this isn't that bad, I think of it as a win. And if they actually start liking it, I think that maybe I've done the truly impossible.
I think that maybe this is a good time just to define organic chemistry. One thing I see in the graphic novels is a lot of talk about carbon. And so for the uninitiated, what is organic chemistry in broad terms?
Yeah, you hit the nail on the head, Steve. You already know the answer. It's literally the chemistry of carbon.
Why is it so hard? Why do people find this so difficult, organic chemistry?
Yeah, I think it's a little bit of a double-edged sword. So a lot of people, I think, are hoping it's going to be this situation where they can memorize things and get by. But it's probably hard because it's not just memorization. It's all about patterns, logic, and problem solving. And the molecules don't just sit still. They react, shift, and sometimes they'll stab you in the back. Looking at you, carbocation rearrangements. Yeah. If you know, you know. All right. Yeah. Plus, the way it's usually taught makes it feel like you need these psychic abilities to predict reaction mechanisms. But once you crack the code, it's actually kind of fun. It's like solving a giant puzzle, but maybe one with a little bit of an existential crisis.
That's what I always think of people who know how to play music, that it's this kind of mystical thing that magical ability that they have. I look at chemistry and I think it's almost like reading music, something that I don't know how to do.
Yeah, 100%. But importantly, you could learn it if you wanted to. And I think that's a big thing with these new graphic novels that are coming out. I really want people to have this idea that organic chemistry is something they could learn if they wanted to. It's not impossible.
And talk a little bit about what a weed out course is. Organic chemistry is sort of infamous for being a, quote, weed out course. What does that actually mean in educational terms?
Yeah, you're absolutely right. Organic chemistry does have this reputation of being the academic equivalent of the Hunger Games. Many enter, but few survive. It's a weed out course for careers like medicine, pharmacy, dentistry, and chemical engineering because it requires critical thinking, problem solving, and a borderline obsessive attention to detail. But is that perception really fair? I don't think so. The way it's traditionally taught can make it feel unnecessarily brutal, when in reality, it's just a new way of thinking, like learning a language with more arrows and fewer vowels, or like the music you were just describing. The real tragedy is some brilliant future doctors and scientists get scared off before they even have a chance to see how cool this stuff actually is, which is, of course, why I wrote my books, to fight the fear and stop this molecular mayhem.
And what kind of strategy did you use going into this to help students better understand the subject?
When it comes to the strategy of this, I guess you need a little bit of a backstory on me. So I've been teaching organic chemistry for 15 years. And that really means I've taught thousands of students organic chemistry I used to work at Ohio State and now I work here at WPI. Both are great students. But the same struggle I saw at both institutions. And over my time teaching all of this, right, I could see the same issues come up year after year where students face the same problems when they were trying to learn the material. And on top of that, I really love art and graphic design, and I got myself a little bit bored with some of the textbooks that we were, requiring the students to use. And so I thought there would be this great space in between the two to introduce almost like a little graphic novel cliff notes so students could use it to go between the sort of like the hardcore textbook and the introductory space they might be in where they're feeling a little nervous about the topic still.
That's interesting because you just said you've been teaching students for many years.
Well, not that many years.
Teens-ish years. So you must see things that they don't see in the moment that, okay, they're going to be hitting this road bump any day now. I'm going to get a bunch of questions on this. Is that sort of what guided what you were going to put in these graphic novels, the trouble spots?
Yeah, no, 100%. So over the course of these years teaching, right, sometimes naturally I would start talking about chemistry in these more colloquial terms, right? Like how's a carbocation going to feel happy? What carbon is the carbocation going to be most happy at? And I would get feedback on my student evaluations of instruction that students really loved this and that they wish I would do more of it. And so I think that really helped solidify the opportunity of using puns and kind of colloquial terms and jokes to talk about chemistry and how students might relate to that.
Is there something in these graphic novels that you're particularly proud of or that you thought was really clever or that kind of made you laugh when you got it back and read it?
And so some of the things that I'm proud of, I really liked how the first two pages came out in the very first book, the one where she's talking about what organic chemistry is, and then the second page where a mermaid is asking a narwhal, if you could be anything in all the world that's magical, what would you be? And the narwhal's like, well, I'd be carbon. Carbon's the most magical thing in all the world. And I thought that was just a really sort of interesting way to represent carbon, right? Because even if, a narwhal and a mermaid want to be carbon, it must be pretty special. Yeah.
Absolutely. And Anton, your illustrator, he's not a scientific person. He doesn't have a background in chemistry. What was that like working with someone who you have to, explain to him these concepts and ideas and he has to visualize it? How did you guys work together?
Oh yeah, Anton is great. So full disclosure, so Anton lives in the United Kingdom. I have never met him in person. And so we met once on Zoom, but we almost email daily, maybe like 5 or 6 times a day. And so we're in constant contact. And he is not a scientist. This is something we sort of talked about early on when we were developing this project. But he is willing to learn. So he will watch videos and do a little digging into the content to try and help understand it. However, the great thing about the textbook pages are they're for a beginner. And so, Anton is like my first test study. Like, can he understand what I'm trying to convey in my art or, humor? And can he convert that into an illustration that whatever audience might be reading it would appreciate? And so I actually think it works out to our advantage that Anton is not a chemist, because he sort of is able to help decipher what I'm saying for a person who doesn't understand chemistry at all. And on top of that, what I've noticed is he introduces interesting elements into the work that I hadn't thought of, right? Like sometimes I'm not really great at drawing people. And so I tend to draw like a lot of stick figures to him. And what he can do is sort of extrapolate some properties of, say, an element or a molecule or a functional group into the person, right? So for example, bromine is sort of further down on the periodic table. So if we're trying to represent bromine as a person, we might make up a person who's sort of bigger, and bromine can be like a good nucleophile, so maybe like something willing to attack. You see what I mean? And so we're able to translate some of these chemistry properties into like a person, and Anton helps like navigate that space in a really, really great way.
Wow. So the theory is if he gets it, then the reader would get it.
Yeah, hopefully, or at least we're well on the way to the reader understanding it better. On top of that, he's like a beautiful illustrator, right? So he actually came up with like that, the molecule sitting in the therapist's office chair, sort of the depressed oxygen, wishing he was a little more stable. And it's actually on the cover of the very first book. And he and I had joked that is like so adorable. We absolutely need to make it into like a stuffy, or as Anton would say, a plush toy.
Or a t-shirt.
Exactly. It's like so cute, right? And so he brings like these elements, just of real cuteness to it all.
Your career has led you to take a particular interest in the intersection of organic chemistry and visual design. Is that a natural pairing? How did you come to this point? Talk a little bit about your history. We know a lot about your history with chemistry. How did you come to realize that, hey, I can combine these things? I can combine my passion for art and visual design with my training as a chemistry educator.
Yeah, I agree with you. At first glance, organic chemistry and visual design seem like a really odd couple, like a scientist dating an artist. It's hard to see how it all works. But in reality, organic chemistry is a very visual science. So we're all about seeing patterns, recognizing structures. And there's even this element in the field where people pride themselves on drawing these fancy organic molecules really beautifully. And, back in grad school, PowerPoint and things like that weren't quite as popular. So we would do a lot of work right on the whiteboard or the chalkboard. And it was always like this point of show personship that you could draw something like really beautifully with like proper sort of bond angles and like trying to depict it in 3 dimensions in a 2-dimensional space. And so I think I was naturally drawn to organic chemistry as a science because of all of this visually appealing aspects to it. The problem is most textbooks present it in sort of this really dry way. And so they're almost actively trying to make students suffer through it when you could depict it so beautifully. And I think on top of that, I've always been a visual thinker, and somewhere along the way, I started to realize, probably after these years of experience being an organic chemistry professor, that if you show people the logic behind organic chemistry, rather than just telling them, it stops being so intimidating. So I took my love for chemistry and my love for art and my general refusal to accept that learning has to be painful, and I smashed them all together into this series. And it turns out, at least from my perspective, science and art aren't so different. They both tell stories, they both solve problems, and they both involve a fair amount of trial and error.
Before you embarked on this project, were you into graphic novels? Were you interested in them? Had you been exposed to them?
Honestly, as a young person, I never. I was not into comic books, anything like that. I do have 2 kids though right now, 2 young kids. So I have a 10-year-old and a 3-year-old. And I would say right now it's the case graphic novels are all the rage. It's really actually quite frankly hard to find a regular plain old chapter book for these kids to learn how to read. And so I'm pretty in tune with, I think, what the young people are reading right now. And so I have read actually quite a few graphic novels at this later stage of my life. Incidentally, I've also been in a lot of bouncy houses lately. It's the life with kids.
Comes with the territory.
Yeah.
I love graphic novels. At the Worcester Public Library, one of my favorite places to go, they have this entire wall of graphic novels that I just kind of randomly pick them sometimes, and you can get so surprised. And it's sort of low barrier to entry because they're quick to get through, very visual, obviously. Was that a thought when you were deciding sort of what vehicle to help people understand organic chemistry better?
100%, absolutely. So yeah, I was just saying, I have these kids, right? And so I can see what they're naturally drawn to. It's a huge benefit when even teaching college students, right? Because I'm sort of seeing how, my kids, my daughter and my son will grow up and be sort of college students one day and trying to reach them where they're at, right? Instead of sort of teaching organic chemistry like I understand it, maybe trying to find a common ground with the students. And seeing my own children really enjoy the graphic novels, and then even trying out my own jokes on them, the own humor I'm using in here. It's really fun. In fact, I have sort of given these to some classrooms at my daughter's school. So my daughter's in 4th grade right now. And she's always so proud to say how much the kids had loved them. I don't know how much chemistry they're picking up from it, but if nothing else, hopefully it's making the organic chemistry seem less intimidating. And maybe when they get to college, right, they'll be looking at it optimistically when they see it on their class schedule.
Won't be so intimidating.
Exactly.
Why is organic chemistry so important to our daily lives? What's an example or examples of organic chemistry that people might not think so much about?
I know. I think you're going to be shocked, Steve, to hear the answer to this one. So organic chemistry is basically the puppet master behind everything you eat, wear, breathe, and slather on your skin. If you ever enjoyed coffee, taken medicine, or worn clothes that didn't dissolve in the rain, congrats. You've benefited from organic chemistry. One of my favorite activities is having students think of their favorite food and then look up the organic molecules responsible for that food's taste and aroma. It's always an eye-opener because if you like to eat, you like organic chemistry. It's that simple. The vanilla in your ice cream, that's vanillin. The mouth-watering smell of bacon, that is an organic reaction. Even the citrusy zing of a lemon comes down to its molecules like limonene. Organic chemistry isn't some distant abstract science. It's literally what makes food delicious. So whether you realize it or not, you're already a fan of organic. You just call it flavor.
Here in front of us, we have 2 editions today of Organic Chemistry, the graphic novel. How many more are there? How many more do you have in the works? What's the plan for this series?
So I'm working on 6 books in total. That perfectly matches up to Organic Chemistry 1 here at WPI. We do cover the same content as almost every other institution, but it just so happens each book here will kind of coincide with a week of organic chemistry during B term. And so in the end, it turned out I decided I would need 6 books to properly sort of train the students with this graphic novel approach. And you're right. So the first 2 books are out. So I was able to publish those electronically on Amazon if you want to check them out. And then I have 4 more books in the works. So Anton and I have finished the illustration for book 3, and that's in this editing phase. Book 4, we just finished up page 7. And then there's two more books left for us to do. So my goal is to have all of the books finished by the end of summer. So when B term does roll around this year, all of the students here at WPI are going to be learning, well, I should say all of the students in my class at WPI are going to be learning organic chemistry through this graphic novel style.
Anita Matson, thank you for joining us on the WPI podcast.
Oh, this has been so much fun. Thank you for having me.
You can find this episode of the WPI podcast and other podcasts on the WPI Insider page at wpi.edu/listen. This podcast was recorded in the Global Lab at WPI with technical assistance from WPI PhD candidate Varun Bhatt.